So I guess we can get started. Yeah, I think the Halloween is at weekend, so I just.
I love you. That's so cute. Can you draw this little character?
No, I just find the series on the internet. Like when I was young, I used this. Like about 10 years ago, I just keep using all of this.
You're so cute.
Thanks.
Do you have a Halloween costume?
What?
Do you have a Halloween costume?
No. You guys have?
Yeah, I'm just being God. That checks out. I'm just like, living my childhood dream. That's so lame. I put it on, it makes me so happy. Even though it's
Yeah, I remember like maybe several years ago, like the Halloween is at Friday. So if I'm working on the campus, I can see different people wear different costume to attend the lecture, which is fun.
We can all come to class on Tuesday, wearing on Tuesday in costumes, but Sunday. Yeah.
Oh, that's good. That looks fun. Okay, so today we are going to talk about ecological risk assessment. I just make sure I'm recording. Okay. And today we have 5 points. So for the first one, I would like to talk more about soil, especially the partitioning about soil. And then I will talk about bioaccumulation. So the partitioning between environments and soil and the environments and biota are also very important. And then I will talk a little about the history of ecological risk assessments and EPA and regulatory related stuffs. And then we are going to talk about ecological risk assessment. We use ecological risk assessment to determine if a site needs remediation or determine if the site is contaminated. And then we are going to talk more about how to quantify the risk. Actually, we have already discussed this in Lab 5, which is hazard quotient. So we are very familiar with this one. So at the beginning, I would like to talk about the composition of soil. And I think you guys may also learn it in other classes. So mainly soil has 4 or 5 components, which is mineral, soil organic matter, gas, water, and organism. So like based on the textbook or different literature, like some of the textbooks say it has mineral, organic matter, gas, and water. So the organisms is not included. But for some other textbook, they say organisms are included. So I just want you guys to know we have like 2 sets of classification system. So the soil mineral are divided into 3 sizes class: clay, silt, and sand. And we can see like we have the soil classification triangle. So based on different composition of these 3 components, we can give the classification of a soil. And the percentage of the particle in these sizes classes is called soil texture. And the most common minerals in soil is quartz. So I think this is the like silicon, something like that. And for the soil organic matter, which is an important component, and so it is a plant, animal, and microbial residues in various states of decomposition. And here shows the example of the soil. But I want to emphasize that the composition of soil organic matter change a lot. So it is not a fixed fraction. So here shows the soil horizon and soil profile. Like based on our experience, we can see that at the very top of the soil, we have lots of soil organic matters. So let's just say this is amount of soil organic matter. And as we go deeper and deeper, the amount of soil organic matter will decrease, which means the soil organic matter are like mainly accumulated at the top of the soil. And for the different layer, we call it soil horizon, and the whole stuff is called soil profile. And in other words, the soil profile is a vertical section of the soil exposed by a soil pit. So for the soil organic matter, we may have something like this. So this is called humins. And from its structure, we can see that it is very large and it has many benzene rings. So it is relatively hard to be composite. And so they are kind of like relatively stable. So I have a question, like, if you are an organic pollutant, where would you like to stay? Like, at different horizon, which one do you like stay? At the top? Because it has lots of organic matters. Yes. So in environmental engineering, actually, we usually care about the top layers of the soil because the organic matter usually accumulated in this layer. And then how can the organic matter stay in the soil or stay in the organic matter? This is related to absorption and adsorption. Like they only have the difference of B and D. So for absorption, it is the process of one material being retained by another phase. So absorption refers to this one. So the chemical gets into the body of another phase. On the other hand, for the adsorption, it refers to the chemical stay on the interface, stay at the interface of another phase. So these are the difference. And in reality, or for the organic pollutant, they can be absorbed or adsorbed by soil. Especially here, the soil refers to the soil organic matter. So they may have like something like this. So we have some of the, this is DDT. We have some of the DDT at the surface of soil organic matter, but we also have some DDT inside the soil organic matter. So both this process will happen, but adsorption usually dominates. So we have more DDT. Usually we have more DDT at the surface, but we have small amount of DDT inside the soil organic matter. This is because the adsorption is usually very fast. And then when the DDT is at the surface of the soil organic matter, it can slowly get inside into the soil organic matter. But this process is very small. So even for a relatively long time, like most of the DDTs are at the surface. But once the DDT inside the soil organic matter, it is relatively hard to extract them out. So like their availability will decrease. And so for this one, do you guys have any questions? No? Okay. And then we have a parameter to describe this process. And here so this parameter is called soil water partitioning coefficient, or sometimes we just call it soil adsorption coefficient, because adsorption is a dominant process. And this is expressed, and this can be calculated by the concentration of the chemical in soil. And in practice or in the lab, we usually use the dry soil matrix. And the CW is the equilibrium concentration in the water. So we have a container, we have the water, and we have the soil. And then we measure the concentration of the pollutant in the water and in the soil at equilibrium. So again, we need to be at equilibrium. And we can also see that based on the amount of soil organic matter, this ability may change, will vary a lot. So the value of KD vary greatly among soil due to organic contents. So basically, the KD will change place by place, or it may also change time by time, because at different seasons, the contents of soil organic matter may be different. So for this one, do you guys have any questions? No? Okay. Yeah, I choose this Pokemon because it is the rock and water which describes this process. The next one, I would like to talk about the organic terms, partitioning between environment and wildlife or human beings. And we also have a term to describe this process, which is called bioaccumulation. So bioaccumulation is a process of accumulation of chemicals in an organism that takes place if the rate of intake exceeds the rate of excretion. Like usually when we get some toxic chemicals, we can just excrete it. But for some of the chemicals, especially for POPs, persistent organic pollutants, because they are persistent, like the biotas, the organisms, they cannot decompose or excrete these chemicals. So they will gradually accumulate in the body of the organism. For example, if we have DDT in the soil, and we know that the earthworms, they will eat the soil, so the DDT concentration may increase. And then, like the fish will eat the worm. But I have some voice here. Okay, anyway. And then the fish will get that DDT. And then the bird will eat the fish. So DDT will come to the bird. So finally, we usually have like DDT concentration is here, and for the worms, for the fish, and finally it will result in very large concentration of DDT in the birds or in the high level of the food chain. And this process is called bioaccumulation. And we can use a parameter to describe this process, which is bioaccumulation factor. So, and usually, like here, it uses the pesticide because pesticide is usually the problem. Like the pesticide in the tissue concentration with respect to the environmental pesticide concentration. And this can, like we can replace pesticides in any of the organic chemicals. And actually we can, any of the pollutants. But usually the POPs are bioaccumulative. So here, BAF is defined as the concentration of the organic pollutant in the organism divided by the concentration of the pollutants in the environment. And here are the units, but the units can be some other units based on your situation. So for this one, do you guys have any questions? No? Okay. So for now, we have learned many of the partitioning coefficients, like this is vapor pressure, this is water solubility, and this is Henry's law constant. This is water octanol partitioning coefficient. This is soil water partitioning coefficient. This is bioaccumulation factor, and this I didn't talk. Oops. This one I didn't talk. So this one refers to the sediment water. Sediment water partitioning coefficients. So this is similar to the soil, so I didn't talk. And in the lab or in the handbook, we usually have this. And in the practice or in the field, we usually have, oops. In the field, we usually have this. And we know this may be side by side and case by case. But all of these values are related to KOW because they are all the interactions between the chemical and the organic phase. So they usually have some functional relations. And so for this one, do you guys have any questions? No? And then we can talk about some history about EPA because we know EPA regulates all of these stuff. So we talk about the Silent Spring was published in 1962. And we also have this Cuyahoga River. Do I read it correctly? Cuyahoga River. I think it's in Ohio State. Have you guys ever been there before? Oh, you have. I just saw the pictures on Google Map, and I think it looks pretty. Yeah, but at that time, I know that it was contaminated by the oil very badly. And then we have the BO2 form, like National Environmental Policy Act was signed. And finally, EPA was established in like 50 years ago. And at that year, I was negative 20, something like years old. I was very young. And here are some pictures of the contaminated river. And when we have EPA also have some compliance monitoring programs. I'm not going to read them one by one, but I think the Clean Air Act and the Clean Water Act are usually mentioned in some other classes. And here I want to talk about Superfund or circular compliance monitoring, which is related to organic pollutant. So the full name of circular is Comprehensive Environmental Response, Compensation and Liability Act. So this is called circular, which was established 10 years after EPA establishment. And for circular, we usually call it Superfund because under this act, we can see the description here. So this is adopted from the EPA website. So if you guys are interested, you guys can go to this website here. Okay, anyway, from this one, we can see that otherwise, so like this act, otherwise known as circular or Superfund, provides a federal Superfund to clean up uncontrolled or abandoned hazardous waste sites, as well as the blah blah blah. So basically, the federal government, they will provide the fund to deal with those problems. So the fund is called Superfund. And this is that. If you guys go to the site, you may see something like this. And this is the Superfund site. And for my project of DDT, it is on our Superfund site. And I think also for Shazad, her research is also on our Superfund site. But usually, we do not recommend you guys to get into the Superfund site. It's not healthy. So for this one, do you guys have any questions? No? And then here comes to a question. They want to, some sites, they need to be remediated. But how can we determine if this site needs to be remediated? Or how do we determine if they are contaminated? And we usually conduct the process of ecological risk assessment. And the definition of ERA is an ecological risk assessment is a process for evaluating how likely it is that the environment might be impacted by a result of exposure to one or more environmental stressors, like such as chemical, land use change, disease, and invasive species. So, except for chemical, we can also have some other stuffs as the stressor. So basically, we have the stressor, which could be a potential threat for the environment. And then we need to collect the information of exposure, especially for the chemicals. We want to know its concentration in the environment. And then we want to know the effect of this chemical, especially for the toxicity effect. And then we can combine the information of exposure and the information of effect to evaluate the risk of a certain stressor, a certain or multiple stressors. The whole process of ecological risk assessment is something like this. So it has 3 phases, but before the first phases, we have the planning. And again, ecological risk assessment is also described at EPA website. So if you guys are interested, you guys can read more about its description on the EPA website. Before the 3 phases, we have the planning. So for the planning, the EPA begins an ecological risk assessment by planning the overall approach with dialogue between different aspects, like the risk manager, risk assessor, and other interested party or stakeholders. And then we have the 3 phases, which includes problem formulation, analysis, and risk characterization. And for the problem formulation, like they gather the information to determine which plants or animals are or might be at risk or in need of the protection. So usually we have the plants or animals, because this is ecological, this is not for the humans. So the endpoints are usually plants and animals. And during analysis, we usually have the 2 components. We can see it here. So for the in the analysis phase, we have the characterization of exposure. So where we want to estimate how much of the pollutant is in the environment. And we also have to characterization of the ecological effect, like what's the response of the animal or the plant to that chemical. And then we can combine the information together to characterize the risk. And so for the risk, here I also want to say that we can see this process looks like it is a linear process. But in reality, when we are doing this process, we may just do back and forth to revise or adjust the whole process. Because as we do something, we find we need some more information, and then we go back to find the information. And after risk characterization, we can communicate with other things, and then we manage the risk. And for the risk characterization, we mainly focus on 2 things. One is risk estimation, and another is risk description. And for the risk estimation, again, we have already talked about, which is hazard quotient. And so for this one, do you guys have any questions? No? Okay. And then we can go to the things that we are very familiar with. So for the risk characterization, we use hazard quotient to measure the risk. We may have some other things, but hazard quotient is the most common one. So this is defined as the ratio of the exposure to a toxicity reference value, TRV, and for the particular type of wildlife being assessed. And here I just say predicted, because for some of the situation we cannot measure the exposure directly. Especially like if we have a site and then we are building a plant, we plan to building a plant and it will have some air pollution, but before we build this plant, we can still do the risk assessment because we can predict the concentration of the pollutants in this area. So we cannot measure, but we can predict. And the hazard quotient is expressed by the CE, refers to the concentration of the pollutant in the environment, or it refers to the exposure, which can be obtained by on-site measurement or by estimation or prediction. And the TRV refers to the toxicity reference value, and which can be obtained by toxicity studies. I'm not sure if you guys have taken any toxicity classes. No? And that is not fun to me. Especially, I think I take the toxicity. It has so many terminologies about the physiology, which is not fun. So anyway, so the toxicity studies can provide information of the toxicity reference value. But for some screening level, we may use some regulatory documents. And here are some examples. So this website shows the ecological soil screening level document So this is for soil, because I'm working on the soil, I'm familiar with this. And we can see it provides the toxicity reference value of different chemicals. So which one do you guys interested about?
Lead.
Lead?
Sure.
What?
What?
Lead? Okay, let's.
We're going to do DDT, that's what
yeah,
you don't want to look at that.
that's fine. I haven't opened this yet, but we can see. So this is a document from US EPA, and we can just go through its table of contents. It's okay. And then we can just see it has some introductions about what's this, and it has a summary of the related studies. And we can see because it is a lead, so it has different forms. But if we are looking at DDT, it only has one form. But we will talk about the speciations of the metals, I think, next week. So anyway, it has some background information, introduction, and then we can find this table. So this table shows the lead ecological soil screening level, and so we can consider it as the toxicity reference value. And we can see it has like the values for different species, like for the plants, for the soil invertebrates, like the earthworms, and for the wildlife, like the birds and some other mammals. So these values can be used in our ecological risk studies. And we can just compare this value and the exposure concentration, and then we can calculate HQ. If we just go ahead, we can see it provides more information. And we can see this is just part. If we can see on the right side, oops, here, we can see this file is very long. But what are the risks? If I remember it correctly, they are just the summary of different studies. Because so this regulatory document is just make the summary of many of the previous studies together to derive this toxicity reference value. Oops. And these are the references. So the real contents are very small, but it has so many of the attachment. So if you guys are interested, you can take a look at. Okay. So as I mentioned before, for the hazard quotient, if it is HQ is above 1, it means it's at risk. And if the hazard quotient is smaller than 1, it means it is safe. And for the risk, I would say it may have the risk, because for the screening level, like the documents I show you guys, it takes the most conservative values. So it wants to make sure everyone is safe. But in reality, we may not, not everything is included. So we may need some further study. Okay. Do you guys have questions about this one? No? Okay. And then we are going to look at some of the examples for the calculation. And actually, this would be the homework, but we have already done in lab 5. So we are not going to calculate it. So anyway, let's look at this example. So the HQ is calculated using a reference mean BAF, which is MLP. So in the regulatory documents, we do not use BAF, we use MLP instead, but they are generally the same thing. As determined by US EPA and is based solely on the contaminant concentration in the soil. And the HQ calculated in this manner is given in this one. So this is actually HQS in lab 5, because we only use the soil concentration. And in this study, the values for each parameter were taken from ecological soil screening level documents of DDT. And here is a summary here. I also take the Delgin, but we do not use this. And this is for the avian, for the birds, and this is for the mammals. And these are the different So this is a toxicity reference value, and we can also find these parameters on that document too. So in this case, we have the soil sample from one site and the DDT concentration of the soil. Okay, and the DDT concentration of the soil is this. So the question is, what is the hazard quotient of woodcock like this one? And do we need further remediation? And we have already calculated this. So basically, we just plug in CS into here, and we just, because this is a bird, so we use this one. And then we plug in the numbers here, and we can have this one. And after calculation, HQ equals to 1.8, which is greater than 1. So the further remediation or further action is needed. Then let's look at the next example. So everything, I don't know why we have something here. So everything are the same, but the soil concentration have some uncertainties, because for the large field or the large site, we have the spatial variability. And here again, we have the same question. What is the HQ of woodcock? And do we need further remediation? Again, we can use the error propagation equations to solve this problem. At first, when we estimate the mean of HQ, we just plug in the mean of CS into this equation, and finally we can get the same result. And for the errors or uncertainties of HQ, because we can separate the variable, and we can use the error propagation equation to calculate the uncertainty or the error of delta HQ. And finally, the HQ can be expressed like this. We can see we have some uncertainties here. And in this case, we may kind of interpret it like this. So if we assume HQ follows a normal distribution with mean equals to this one, and this is standard deviation, and then we can make a, we can draw this normal distribution. So with mean equals to 1.84, and the standard deviation equals to this. And because the 1 is a critical value, so we can compare this distribution with 1. And in this case, we can see for this normal distribution, the probability that the hazard quotient is greater than 1 equals to 0.93. We can see the probability is very large, which we would say we still need some further actions to do that. And again, as we did in lab 5, the soil has uncertainty, and the toxicity reference value also has some uncertainties, because even for the same species, different individuals may have different sensitivities to the chemicals. So again, in this case, we can separate our variables. So this is x divided by y, and then again we can plug in the CS and TRV into this equation, and then we can calculate the relative error of the soil concentration and the toxicity reference value, and then the relative error of the HQ can be calculated using this triangle equation, and finally we can solve it. So the HQ equals to this one, and the uncertainty is 0.66. We can see the uncertainty increases. Like for this one, this is only 0.56, and this is kind of increase. Again, we can use the similar method to interpret this result. So this is a normal distribution with mean equals to this one, and we have the standard deviation. And again, the probability that the hazard quotient is greater than 1, in this case, is 0.898. So this is also relatively large, and we would say further action is needed. But in practice, what will be the critical value of this? So like we don't have an answer, but we need to discuss with the stakeholder, with some other people to determine what will be the critical value of this probability. And then again, we can still add the uncertainty to this question. So for PS, which refers to the soil ingestion ratio, like even for the same species, different birds, they may eat different amount of food. So we may have some uncertainties. And again, we can use the error propagation equation or the Monte Carlo simulation to do this calculation. I'm not going to do the calculation here, but I just want to let you guys know that even for this equation, we can add uncertainty to every variable. And finally, we can get the risk hazard quotient with an uncertainty. And that's it. So for this one, do you guys have any questions? No? Okay. And then I think this is point number 6 that I didn't show. So I want to show you guys a paper. I don't think you guys will be something like this, but so this paper, we can see it will be published in December 2021. So it will be published in the future. This is because it is just gets accepted. Here we can see it is received in this month, at the beginning of this month, and it is available, I think, last week. And we can see the authors are Maria and me. So actually, we wrote this paper. Yeah, thanks. So during this semester, we are just revising this paper, and finally it gets published. So that's good. And because, like Maria and I write this paper, and we are doing our research, and we also do the teaching, you guys can imagine that the teaching content is pretty related to what we are doing. And here I think I can show the paper. So that is 411, and upload file lecture slide. So we have this paper here, and we can see the title is On-Site Evaluation of the Effects of Carbonaceous Amendments on the Bioavailability of Aged Organochlorine Pesticide Residue in Soil. And this is very related to the units of this, to the organic chemistry unit. And actually, I also did some classifications of the content. Like in the introduction part, like this is related to lecture 12, which is the lecture at last week. And then we also have, like also in the content, we have some content related to this lecture, like for the EPA, blah, blah, blah. And something related to lecture 10. What is lecture 10? Sampling? Oh, yeah. And lecture 12, organic chemistry. And for the material and the methods, again, this is related to this one. And for the sampling design, which is related to lecture 6, which is sampling. And lecture 7, which is about the spatial variability. And so this is experimental sites. And again, for the soil sampling, this is related to lab 4. So you guys do the soil sampling, which is very similar to what we have done in our research. And I guess I delete the note.
No, just from that page there.
You couldn't?
The other pages still have them.
Yeah, I still have that in this page, but I lost them in this page. But anyway, I will not save this. And then for the bioaccumulation factor calculation, so this is what we already done in lab number 5. And also, for for the calculation of some of the errors is related to lecture 2. And we also did calculate the hazard quotient. And so this is also what we have done in lab number 5. So we compare the differences between the two HQ processes. And during the calculation, we have the uncertainties. So like we use the bootstrapping sampling. So bootstrapping sampling is the Monte Carlo simulation method. So what we have done is exactly what I used in this paper. And for the Monte Carlo method, I don't have too much shown in the paper because I don't think many people are interested in that. But I provide that in the supplementary information. So for the Monte Carlo method, if we write what we have done, it will be something like this. So I think this process is a little bit long, but it just describes what we have done. So this is what we have done by using Excel. But when I use MATLAB. Okay, anyway, I uploaded this paper in ENCE. So if you guys are interested, you guys can read at least the introduction and the material and the method part. So which is pretty related to this course and similar with the homework assignments, because in the homework assignments, we have another DDT paper, which is also done by our group. Okay, so anyway. And finally, this just reviews what we have learned in this class, in this lecture. So the 4 components of soils include which 4? Minerals, organic matter, gas and water. Yeah. And someone may say it also contains organisms. And soil water partitioning coefficient is defined as of water. And we need to remember it is at equilibrium. And the bioaccumulation can be quantified by BAF, right? Bioaccumulation factor, and which is defined as
the concentration of organisms or the concentration
of the environment at equilibrium. And so circular refers to superfund, yes. But do you guys remember what's the full name? I think comprehensive environment. I also liability, right? Act.
Last one is definitely act. It's always act.
Comprehensive environmental regulation and liability act.
Oh, that's good.
Sounds official. Sounds like someone's reviewed that information.
I will not ask the full name, but it's good to remember it. And you usually call it superfund. Yeah, so we usually call that superfund. And the 3 phases of ERA include
Problem formulation,
analysis, and risk characterization. And ecological risk assessment can be described by the hazard quotient, which is defined as exposure. Okay. So finally, some of the announcements. So the quiz 7 and assignment 5 is due on this Friday, and the quiz and assignments of these units will due on 2 weeks later. And I think I have posted quiz 8 this morning, and for assignment 6, I think Maria is still validating this. So probably it will be posted this afternoon or early tomorrow. Okay, so that's it.
Thank you.